Notice how in this example, this rational expression in the integrand's position is not proper. It's improper because the degree of the numerator is not strictly less than the degree of the denominator. That means I should perform polynomial division, unless we're tired and we're too lazy to do that. We could just add a funky looking form of 0 instead, but it's your choice. That term is this term times x. So multiplying the remaining two terms by x, this fraction will reduce to an x. Now, I did forget this term here. And I suppose I did forget this term right here, but when I compensate for this, that leaves me just 4 of them. Now I put this term in to compensate that, or add 4x to that. But here too, when you look at this term right here, it's twice this first term. So let me multiply the remaining two terms downstairs by 2 as well. I should say by -2. If I do, this fraction right here reduces quite nicely down to a -2. But again, compensating. And I'm merely double checking my arithmetic. I like it. As I suggested, this term right here cleans up quite nicely. Now that this right here is a proper rational expression, I'll commit to partial fraction decomposition. First things first, let me factor the denominator. Excuse me. Now I know the rational root theorem tells me what I can try as a rational zero for this function over here. But since the coefficient is added to 1, you know that this is going to be a rational zero, but that polynomial. And now let's commit to that partial fraction decomposition. Getting rid of fractions. Allowing x to be the zero of that linear factor. Perhaps equating coefficients of x squared. Perhaps equating constants. And now there's too much to remember. We can anti-differentiate these three terms piece of cake. But as far as this one's concerned, let's again massage that numerator in such a way that it's a multiple of the derivative of my denominator. So it just gives me a 1 over u with a u sub. What remains over here is a constant over this trinomial, but we'll massage this by completing the square, and we have an inverse tangent. This denominator's derivative is 2x plus 1. The constant 1 is half the coefficient of x. But here the coefficient of x is 3. So half its coefficient is this. I'll compensate by adding a negative 3/2, this negative 2. So bringing the negative 7/2 to a whole nother fraction. Completing the square of my denominator. Looks good. I think we're done. Now we can just state the answer. And maybe finishing up just a tad bit by combining some logarithms. That's what I might consider a test-worthy question.